Hey, what's going on, guys? Let's do this problem right here. We have integral of 1 over 9x square minus 25 power 3 by 2. So let's rewrite this one as integral of 1 over, we know that 1 over 2 mean that's a square root, right? So we can write this one as, also I can write this one as 3x square minus 25, because we are trying to bring one of these pattern right here. Then only we can do this trigonometric substitution. So let's write this one as 3x square. I have to use the eraser. Okay, here we go. 3x square minus 5 square, and this is all in the square root, and we know the square root also power by 3, because 1 over 2 is square root, and the top power is going to be the power. So we have this one right here. Now we can do this trigonometric substitution. If you look at this, we have a variable minus number. In this case, this is number minus variable, this is variable minus number. So this is the one we need to use. This is the one we are going to use. So in this case, first of all, x is going to be equal to, in this case we have 3x. So 3x is going to be equal to a sec theta. A is the number, here we have 5. So that's going to be equal to 5 sec theta, right? And if I find the derivative of this, let's rearrange this one. X is equal to 5 over 3 sec theta, and the derivative of this one is going to, dx is going to be equal to 5 over 3. Derivative of sec theta is sec theta tan theta. So it is going to be sec theta tan theta d theta, right? D theta. Now we can write everything in terms of trigonometric variables. So let's rewrite this in terms of, we have a dx, so it's right here in terms of trigonometric variables. So this is going to be, instead of dx, I'm going to plug this one. So that is 5 over 3. I can, since this is a constant, I can write in front of the integral. So this is going to be 5 over 3 sec theta tan theta, and also we have a d theta. In the bottom, we are going to have 3x. We know that 3x is equal to 5 sec theta. So this is going to be square root of 5 sec theta square. And then we have, what else we have? 5 sec theta minus 5 square, that is 25. Now we can simplify this one a little bit more. The first thing we try to do, try to get rid of this square root. That makes everything easier. So we have 5 over 3 right here, and on top we have sec theta tan theta, and in the bottom this is going to be 25 minus 25 sec square theta, 25 sec square theta minus 25, and already we can already see we can take the 25 common. So let's continue here. Here we have 5 over 3 integral of, also we have a d theta right here, and this is sec theta tan theta, and in the bottom we can take the 25 common right now. So this is going to be sec square theta minus 1, because we took the 25 common, minus 1. Then we have d theta. We can take the 25 out because it's 5, right? So we can take this one out. And then we have to get rid of this one too, because we have to completely get rid of this square root. So what we can do right here, we can do the trig identity. We know that sec square theta minus 1 is equal to tan square theta. So sec square theta minus 1 is equal to tan square theta. That's what I'm going to substitute instead of this one. So that will make everything out of the square root. So this is, let's take this one. So 5 over 3 integral of sec theta tan theta, and I can already take the 25 out. That's going to be 5. I can multiply here. So this is going to be, I am already making a mistake right here. I forgot to put the power 3. So we have a power 3. We have to be really careful. Power 3, right? So if I take the 5 out, this, if I take the 5 out, and that's going to be powered by 3. So if I take this one out, so 5 power 3 square root of cos, this is tan square theta, right? Tan square theta, then this is going to be power 3, right? This is going to be power 3, and I can bring the 5 power 3 to the front. So let's do this. 5 over 3 times 1 over 5 power 3 integral sec theta tan theta. I can take the square root out, so this is going to be tan theta, and that's going to be powered by 3. So this is going to be tan cube theta right now. So tan cube theta, and also we have d theta, d theta. Now we can cancel one of these 5 right here. So if I cancel this one, this is going to be square. So we have a square, and 5 square is 25. So we can multiply this one. This is going to be 1 over 75. 25 times 3, 75. Then we can cancel one of these tan. This is going to be tan square right now. So this is going to be integral of sec theta tan square theta and d theta. Now what I'm going to do, I'm going to write everything in the basic pattern. So 1 over 75, we know that sec theta is reciprocal of cos theta. So let's write this in terms of that. So this is going to be 1 over cos theta multiplied by, you know, tan theta is sine over cos. So it's in the bottom. So if I write this one in terms of sine over cos, the cos is going to be flipped over because it's in the bottom, right? So this is going to be cos square theta divided by sine square theta d theta, right? Now I can cancel one of these cos theta. So this is going to be cos theta over sine square theta. So this is going to be 1 over 75 integral of cos over sine. We know that is cot theta because that's reciprocal of tan theta. We know that tan over sine over cos is tan theta. Since we have cos over sine, that's going to be cot theta. Cot theta, if I take the cot theta, I have one more sine left here. So that's 1 over sine theta. So reciprocal 1 over sine theta mean that's cosec theta, right? Cot theta, cosec theta, d theta. And we know that this is the derivative of cosec theta. If you take the derivative of cosec theta, that is minus cosec theta cot theta. Since we have plus right here, that the integral is going to be minus 1 over 75 cosec theta and plus constant, because we are taking the antiderivative, so this is going to be plus constant. Actually we have almost done, right? We have reached the final thing, and now all we have to do is bring this one into x pattern, because we are trying to find integral of this one right here. We substituted trigonometric substitution, so we have to bring it back. So let's do the triangle. So in the beginning we have take this one right here. 3x is equal to 5 sec theta. We know that sec theta is reciprocal of cos theta. So let's write this one again. I use a different color so that makes everything clear. 3x is equal to 5 sec theta, right? So sec theta is going to be equal to 3x over 5. We know that sec theta is reciprocal of cos theta. So cos theta is what? Cos theta is adjacent over hypotenuse, right? Hypotenuse. And since this is reciprocal, we know this is hypotenuse over adjacent. So this one is hypotenuse right here, and this is adjacent. So if I take the theta, this one, 3x is going to be hypotenuse, and 5 is going to be my adjacent. Since our final answer related to sine theta, because cosec theta is 1 over sine theta, we need the opposite side. So we are going to use the Pythagorean theorem. So according to Pythagorean theorem, this minus this, square of this minus this gives us this value. So this is going to be square root of this square. This is 9x square minus 25. So we have the opposite right now. Now we can write everything in terms of x. So let's write this one in terms of x. So we have minus 1 over 75 cosec theta reciprocal of sine theta. So that's going to be hypotenuse over opposite, right? So hypotenuse is 3x over square root of 9x square minus 25 plus constant, and that is our final answer. I hope you guys liked this video. See you next time.